All right. One of the disadvantages of this online thing is that if you don't do your work by noon or 1, I don't know how you're doing if you wait till the evening. So I think about 3 of you had it done, and I know some of you are having problems. So I just want to go over the homework. Hopefully I do it right this time. So let's take a look at the calculations. The first couple were pretty straightforward. I didn't foresee any issues there, but I want to talk about this one. Calculate the pH of a 0.5 molar solution of acetic acid and a 0.9 molar solution of sodium acetate. All right, so this is a buffer problem, right? The buffer is the a weak acid, acetic acid, with the salt of its conjugate, right? The salt of the anion, right? So sodium, the acetate part here is the anion, and that's the mixture of the two. And to do this, you can do the ice chart and have fun with that, but really it's easier to use the Henderson-Hasselbalch equation. So all I'll do is the pH equals pKa, so I take the negative log of 1.8 times 10 to the minus 5, add that to that the log of the base, the acetate part, whatever your salt part is here, so boom, 0.9 molarity, divided by the acid, the concentration of the acid, which here is 0.5. And now we just solve for it. The negative log of 1.8 times 10 to the minus 5 is 4.74. Plus the log then, if I'm doing this right, 1.8. Divide those two. And I end up with 4.74 plus the log of 1.8 rounded up to is 0.26. So my pH is 5 exclamation points. All right. Again, I think the hard part of this equation is remembering this part. Otherwise, it's pretty basic. Let's take a look at the next one. All right. Well, technology is really irritating me right now. I can't move this to the center, and that's just kind of irritating me. All right. So this one is the weak acid problem. We have a 0.5 molar solution of acetic acid. The Ka is 1.8 times 10 to the minus 5. And I did delete the equation. So let me pause it and rewrite it, and you'll see some magic. All right, boom, there it is. So we're going to do, and I believe this Ka is correct. It's 2 times. We use that now. So let's take a look at ice chart. Initially, I have a 0.5 molar solution of the acid, 0 of each. It's going to be subtracting the 1H, 1 anion per plus X. So this becomes 0.5 minus X. This becomes X, and this becomes X. I'm a little nervous about this 10 to the minus 5 being a little bit too large for us to eliminate it, but we're going to go ahead and eliminate it and we'll see what if our assumption is right at the end. So then we end up with our equation. Again, products over reactants, the concentration. If you don't remember, I'm sure there's a video out there that I've done already. It explains that. Minus X will drop it, see what happens. So I end up with 1.8 times 10 to the minus 5 equals X squared over 0.5. Multiply by both sides by 1.5, and I haven't done this one ahead of time yet. Not 15. I screwed it up, but I caught it. Now I have TI30XA somehow. I don't know, maybe I'm in some sort of technological dead zone because nothing wants to work for me right now. Not even my TI30XA, it's just frozen. What in the heck's going on here? Well, I was getting nervous there. Nothing was working, but apparently I pushed the button too hard and got kind of turned on, and it wasn't going off. It's the back button. Anyway, so when you do this multiplication, you get 9 times 10 to the 6th. Sorry, 9 times 10 to the minus 6th equals X squared. And we're going to take the square root of both sides. So we get 0.003 is X. And now to get the pH, So this X, remember, is my concentration of H+, which was over here. Right? It's also the concentration of the anion, but we only care about the H. Hit the negative log, and you get a pH of 2.52. That's right, 2.52. All right. All right, I'm going to do one more. This was 2 nights ago, not yesterday. And as you can see, it's still giving me fits. So I'm just going to have to leave the text here. Oh, well. All right, so we have our equation H2O2. It's going to dissociate H plus HO2 minus. Oops. And I'm doing this because I noticed at least one or two of you got this one wrong. So we'll see. Maybe we'll find what happened. I don't know what happened. So you have a 0.88 molar. By the way, this is, I looked it up. If the internet's correct, and you can't always believe everything on the internet, then that is the concentration of your hydrogen peroxide that you get from the store. I believe it's a 1% solution. So I thought that was kind of cool. 0H plus, 0H2O minus. Might change. Man, this is just getting to be repetitive, right? Minus X plus X plus X. The equilibrium is 0.88 minus X, X, X. I put that back into my equilibrium expression. Remember, products over reactants. And I'm going to really try to shortcut this one. I end up with X squared and 2.4 times 10 to the minus 12 all over 0.8 minus X. I'm going to drop that X this time. It's pretty small. By the way, never mind. I'm going to keep going. When I multiply 0.88 into that, I get X squared equals, where am I? 2.112 times 10 to the minus 12. I take the square root of both sides, and my X is going to equal 1.45 times 10 to the minus 6. And then to get the pH of that, I take the negative log, which ends up being 5.84. That's your answer. If you're wondering that last problem that we did with the, I don't remember, where the acetic acid, K is minus 5. If you use the number we had, 0.003, and subtract it from 0.5, you do get 0.497. So there's a little bit of error there. And if you're wondering, anyway, please feel free, just ask me questions. Send me an email or something if you are confused on a problem. See ya.